Welcome everyone to my LeetCode Biweekly Contest 128 livestream. If you're here for solutions, jump ahead to 90 minutes in or use the timestamps in the video description. In a few moments, we'll be starting a contest. We will be giving hints, we'll be clarifying questions live in the chat. We won't be sharing code during the contest, but immediately after it ends, we'll go through solutions for all 4 questions. So stick around. If you enjoy LeetCode content, make sure to check out the rest of my channel. I have solutions to different problems. I have solutions to question 4s from previous contests, and I have general tips on just tech interview. And as usual, like and subscribe to stay up to date on new videos. Alright, the contest is live, so welcome everybody who's here. 90 minutes in, or use the timestamps in the video description. In a few moments, we'll be starting a contest. We will minutes in, or use the timestamps in the video description. In a few moments, we'll be starting a contest. We will minutes in, or use the timestamps in the video description. In a few moments, we'll be Hi everyone, welcome. The contest has started. So feel free to join us. Type in the chat if you need help. Hi everyone, welcome. The contest has started. So feel free to join us. Type in the chat if you need help. Hi everyone, welcome. The contest. Hi Vinod, how's it going? Test has started. So feel free to join. Let me know if there are some aberrations in the sound. I think there's something wrong with. I hear some aberrations in the sound, but if there are, let me know. Good luck, everyone. Hope your contest is as good as. Hope your contest results are better than the last one. Are there still echoes? Hi everyone, welcome. The content. Hi everyone, welcome. The content. Hi everyone, welcome. If there's still echoes, then I might just turn off the sound and communicate with you guys via the chat. I don't know if that's gonna work very well, but we'll see. Question 1 solved. Well done, technology world. Hey Rohan, I'm very good. Nice to see you again. Okay, I see some questions. Can you explain question 2? First question done in 7 minutes. Yeah, very well. Nice. Good job, Rohan. Can you explain question 2? Sure. Let me come to question 2. Okay, question 2. You're given a 2D integer array points, where points is x, y. You're given an integer w. Your job is to cover all the points with rectangles. Every rectangle has lower point at some x0 and upper point at some xy. So x1 is on the left, x2 on the right, y larger than 0. And there's this constraint, x1 minus x2 smaller equals to w. Do you know what that means? So x1 minus x2 smaller than w means that the width, essentially the width of the rectangle must be at most w. The rectangles can be any height. In fact, your rectangles should be infinite height, so that you cover all the points. The only constraint is on the width of the rectangle. The width of the rectangle must be is at most w. So how do you want to do this? Well, here's the thing. Find how many rectangles you need whose width is at most w. They will cover all the points. So all you do is look at the x-axis of the different points and where they land, right? You look at all the x-axis of the points. You only look at x-axis, don't look at y. Let me see if I can type here. Max width of the rectangle. So what you want to do is to only look at the x-axis, x-coordinate of all the points, and then what you do is you pick, let's say, this point. You see how far you can go with one rectangle, right? These guys are all less than or equal to w spaces away from the first guy, so they all fall in the same rectangle. So this guy is not, so he has to use his new rectangle. Does that make sense? So you go through all the x-axis of the points. You see when's the last time you started a rectangle. Can you join the current rectangle? If you cannot join the current rectangle, start a new one. And then at the end, you count how many rectangles you have. Yeah, I hope that was helpful. If not, I'm pretty sure I'll have to describe it again. So hold on to your hats. Okay, let me see the chat. Question 3 is very interesting. Can I explain question 2? TQ for question 2. Okay, cool. Question 3, does MST work? Question 3, I think normal Dijkstra would work, but you have to modify it. You have to modify it so that at each point you check for something additional. Which is, I guess, Dijkstra is a kind of spanning tree, right? Not super sure. Minimum spanning tree. Because you don't just need to, yeah, so I think you need some kind of Dijkstra. Yeah, I think it's just some kind of Dijkstra. Okay, please explain question 2. Question 2, you don't have to use a tree. So let's see if I can come back. Question 2. So what you do is you go from left to right. Go through points from left to right. For each point, if so you go from left to right. First you sort the points, and then you go from left to right. You look at the x coordinate of each point. If the point's x coordinate is larger than w units from the start of the last rectangle, so let's say this guy over here, let's say here, there's no rectangle, right? So you start a new one. Start new rectangle. This guy over here is 1 unit from the start of the rectangle. So they're okay. This guy over here is 2 units, so they're all okay. So these two people are all in the same rectangle. Okay, then you get to this guy. Hey, this guy is now 3 units away from the start of the previous rectangle. That's more than W. So you have to start a new rectangle here. And then you keep on going. This guy, oh well, he's less than W units from the start of last one. This guy, same thing. And now you start new one. So you count how many rectangles you start. I hope that was helpful for question 2. You don't actually need a tree for question 2. So for question 2, you just go through, the hint is, y coordinates don't matter for question 2. It's only the x coordinates. I hope that's helpful. I got to go back to doing my own contest now. Code, please, or question 2. So we don't share code here. We can't share code. Is it's LeetCode policy. Anyway, it's a contest. You want to do it yourself. How to get perfection? Oh, I'm definitely not perfection. I can talk more about intuition, but you know my contest ranking is not very high. My code for question 3 tier. What I think is my optimization. Yeah, well, I'm still working on my code for question 3. I don't know if mine will TLE. Hopefully not. So the n is pretty big. So the n is 5 times 10 to the power 4, which is 50,000. So if you can have one nested for loop. So I think you have like one nested for loop. That's the limit. If you have more than n square, anything worse than n square, then your answer will TLE. Any hints from question 2? Let me come back to you in a few minutes. I have to work on my own contest. The hint for question 2 is what you see on the board, basically. So ignore all the y coordinates, just look at the left coordinates. W is the max width of the rectangle. So you go from left to right for each point, you check if your x is more than w units from the last time you started a new rectangle. If it is, then you start a new one. That's the hint. Sorry, I'll give you a more detailed explanation later. Question 3, please. Give me a second. Okay. I'll explain question 3. Okay. Question 3 is C Ninja done. Very nice, very nice. You're done with C Ninja SM. Are you done with all 4? That's very nice. Okay, I'll explain question 3. So question 3 is minimum time to visit disappearing nodes. You're given a graph that looks like this. Sorry. You have a graph that looks like this, and then what you're given is also a disappear. This disappear. Okay? Disappear will tell you what time things disappear. past a certain time, the edge would basically let's see. Yeah, the node will disappear and you can't use it anymore. Okay, so that's how it works. So for instance, you get from 1 to 2, it costs you 1. Okay, so for instance, from 0 from node 0 to node 2, you cannot actually use it because sorry, I'm fumbling over my words. Well, basically the bottom line is at this point, at time 1 and time 5, the respective node will disappear. So it's like their node never existed, which means that if you try to get from 0 to, let's say, from 0 to 1, right? If you're trying to get from 0 to 1, node 1 disappears at time 1. So because it takes 2 units of time to get from 0 to 1, node 1 will disappear before you actually get there. That's why it's unreachable. Does that make sense? That's how disappearing works. So the disappear node says when you try to get from here to here, and basically the disappear node says at this unit of time, at this point in time, this guy will actually completely disappear. So that makes you first, you're unable to visit that node if you cannot get there before it disappears, and 2, if you need that node to get to the other node, then you will not be able to use it before it disappears. So for instance, in this example, you want to get from 0 to 2, right? You want to get from 0 to 2. So the fastest way, there are 2 ways you can get from 0 to 2. One is you go through here. This will cost you 3. And then the other one is to go to here, which will cost you 4. So you might think, I'll use the cheaper path, go through node 1, and that will only cost me 3. But the catch is, node 1 disappears at time 1. So by the time you get to node 1, you take 2 units of time to get to node 1, it will have disappeared already. So you can't get to node 1. You can use it to get to node 2. So that's how disappearing works. Okay, so how do you do this? Basically, it's the same as Dijkstra, right? So basically, it's the same as, okay, well, let's figure out what are all the nodes I can reach from 0. I can reach this guy. You essentially set up like, you set up your results. From 0, you can, you set up your result, right? So you create some kind of result. From 0, you take 0 units to get 1. From 0 to 1, can you get to here? From 0 to 1? Well, actually you can't. Actually, you're not able to do that because from 0 to 1, 1 will have disappeared. So 0 to 1 is minus 1. So 0 to 2 is going to be 4. So this is 4. And you keep going, right? And if you find an alternative path, let's say you find an alternative path that is cheaper. So now 0 to 4 will go through node number 3, which only costs 2. Then you can update this. So this is actually the same as Dijkstra, if you know Dijkstra already. Does that make sense? Yeah, so the idea is you keep some kind of to-do list, where the to-do list of all the paths, all the nodes you can reach that are reachable. And then every time you find a new node where you can reach in a, that's cheaper than the best time you found so far, then you add it to a to-do list. So at the beginning, the to-do list is 0. So you check all the neighbors of 0. Okay, you're done checking, you're done. Okay, now you check to-do list 1. you add 1, 2, and 3 to a to-do list. You check all neighbors of 1. Well, 1 is not reachable, so it's done. And then you keep going until you've done all. I hope that was helpful. I'm stuck on 4. Well, I'm still debugging 3. So once I've done 3, I'll help you with 4. I think 4 looks like a sliding window thing. I think. I think 4 is a sliding window thing. I'm not super sure. DFS got yeah, I think, let me see. Yeah, I think DFS will work. Zero, 1, 2. Interesting. Let me just check the chat. Okay, I'm gonna ask you to stop spamming. Sanatam Diam. Okay. You use priority queue and TLE. Somehow DFS works. Question 4 looks easy. Let me see. What finance do you use? Is it Dijkstra? Yeah, you can use some kind of modified version of Dijkstra. You can probably do some kind of heap too if you want. I think. Yeah. Fortunately, I got a TLE with question 3. So I'm still trying to figure out how to make mine faster. So you guys are ahead from me. Let me look at question 4 real quick. See if I can help out people who are there. Number of subarrays of nums where the first and last elements are equal to the largest element in the subarray. Yeah, so question 4, example 3, example 2 is the tricky one. When all the elements are the same, then you might run into the TLE if you don't. Yeah, you might run into TLE unless you are smart about it, I think. So question 3 hints is what you see on the board. Basically, you basically do some kind of search. It's basically Dijkstra's algorithm, or I think RedFinance had some success with doing a DFS. So I think the trick is if you just visit every node, if you sort the, how do I say this? In Dijkstra's algorithm, there's a heuristic, right? That shows you the shortest distance. That tells you the distance that you have to each node. If you sort the list of nodes by how fast you can get to them, I think you can just search every node only once. So that will make it a little bit faster. Just do a DFS and go over, or that will allow you just go over every node once, which is effectively a depth first search. I don't think you can just do a DFS, right? I suspect you probably have to sort the nodes by how far they are. Anyway. Hints 4. I don't know. I'm also stuck on question 4. I think some kind of sliding window, but I don't think the sliding window helps you very much though, because I think the trick is to start with the biggest element. I'm not sure. Yeah, I don't know. I feel like maybe one thing that I'm also looking at it. I'm not sure how to what the answer is. If I were to guess, maybe one way is to start with the biggest element. Yeah, so you have a long array, right? The biggest element is, let's say the biggest element is 4. Right? So the biggest element is 4. So what you do is then you search for all the 4s. And then you return how many based on how the number of subarrays. Yeah, let's say there are 2 4s, then the answer for 4 is 2. If there and then after that, because once you have the 4s, okay, let me see. So this is what I'm thinking. right? So let's say you have an example like this. So here's what I'm thinking. First, you start with all the biggest elements. Okay? Since they're the biggest elements, everybody is smaller than them. Since everybody is smaller than them, then yeah, just count where they are. That's how many there are. So let's say this is 4, right? So since there are 2 4s, the answer for 4 is 1. So there's exactly one what do you call that? Perfect subarray. Yeah, whose first and last element is 4. And once you're done that, you eliminate all the 4s. Okay? And then you're left with basically three sort of sub-problems. And then now you move on to, let's say, the 3s. Right? So you tackle each sub-problem independently. So in this particular sub-problem, the largest number is 1. Right? So since the largest number is 1, this subproblem 1 will be 1, and this one subproblem 1 will be 1. And then this subproblem 3, 2, 3 in the middle, you do the same thing. You look for the largest number. The largest number is 3. Okay, great. Where are the 3s? The 3s are here and here. There are 3 3s. There are 2 3s. So the answer here for 3 is also 1. And once you've done the 3s, you cancel them out. And then you're left with this as a subproblem. Yeah, I think that's how you do it. That's how I'm going to do it anyway. I hope that was helpful. I don't know whether that's right. I think that's correct. Yeah, that's what I'm thinking. Yeah. So Sahau Agro, I'm gonna ask you to stop spamming. Yeah, you have to do the normal Dijkstra, but instead, besides checking distance condition, you need to check if the node is disappearing or not. Yeah, that's how you do it. Unfortunately, I'm also getting a TLE. That's what I'm doing, but I'm using a priority queue also, and I'm still getting a TLE. So I'm not sure why. think there's some bug in my code. Pretty sure there's some bug. Yeah, I use PQ, so I'm also still getting TLE. Anyway, I am going to try question 4 and then see how it works. I think question 4 you can use a tree. Some kind of tree. Yeah, question 4 I might use some kind of tree. I'm also thinking about it. So let's say for input like this 1 4 3 2 3 4 1, I'll have root of the tree. I'll have 4 4 1. Oh, actually you cannot use a tree. What am I thinking? Segment tree. Segment tree. Segment tree. Yeah. I don't know. Yeah, I feel like it's one of those. You use sliding window, stuck for the condition for 3 to 3. How to move the second one. Number of BST is where we want to make the root min equals min. Yeah, I don't know. I'm also just as stuck as you guys. Sliding window, I don't think sliding window will work. Because like if you think about it, let's say my sliding window currently the left hand side is 1. Okay, and I solve the answer for 1. What do I do next? If I move the left pointer 1 step and that becomes 4, then I have to sort of resolve the whole thing. Yeah, maybe not. Maybe sliding window will work. Let me think about it a little bit. Yeah, if the second larger element is larger than the first element, then move left by 1. So you can move left by 1, and then your right can keep moving, right? Then your right can keep moving. Yeah, but yeah, not sure. Yeah. Question 4 is quite difficult. Yeah. I'm kind of stumped also. I feel like, so first of all, I want to say, I really love how everybody is throwing ideas in the chat about question 4. Because the more you think about a problem, the more you discuss with other people, the more you learn, right? That's the whole point of this exercise. It's not to become the best contestant, whatever. That's bullshit. That's like worthless. You want to get better at programming. So having that discussion right here in the chat, that's a good way of learning. And I'm learning too. As you can see, I'm also stuck on question 4. Kind of sucks. Yeah, so Dead Shoe Live. Sorry, we don't share code here. We don't share code here. Because it is a contest, so we want to be fair to everybody. We want to like not cheat. We will discuss the strategy for getting the solution, but we will not actually share any code. And the strategy for 3 apparently is somebody had luck doing just a simple DFS. It's I think the sort of correct-ish solution is to use Dijkstra and then modify it. So modify your Dijkstra. Yeah, just the right one move. I don't know how to get the left one to move. Yeah, so the 3-3 case is interesting. So Asta Singh, I can explain the question for you if that's what you want. I don't know what the solution is. I think we're all sort of trying to figure it out. So the question is quite simple. You're given a bunch of positive integers nums. You want to return subarrays such that the first and last elements is equal to the first and last elements are equal to the largest element in the array. So for instance, let's say your input is something like 1. Let's say your input is 1 4 3 2 3 4 1. Then this would be a subarray that you want to count because it starts with 4, it ends with 4, and its largest element is 4. This is also an array you want to count. It starts with 3, ends with 3, its largest element is 3. Something like this will not work. Sorry. Something like this will not work. It starts with 1, ends with 1, but its largest element is 4. It's not 1. So this will not be valid. So that's what the question is asking for. Oh, you Pandra, you managed to. Oh, share. Yeah. Can we use deck for 4? How would you use deck though? Yeah, I can't think of. I don't think sliding window will work. Yeah, check the num in the array is greater than the max element. Yeah, so Asta saying that would work for small inputs, but for large inputs, it won't work. Because if you look at the size, you look at the size of n is 10 to the power of 5. So this means that you cannot do a nested for loop. If it's O(n) square, it will fail. It has to be faster than O(n) square. Yeah, I'm gonna try something. I don't know whether this will work or not. Well, question 4 by solved by sliding window. I don't think so. I'm still working on it, so maybe it will be, but I don't think so. So I'm trying the gaps thing that I drew the picture that I drew on screen. I don't think it'll work, but I want to try it. I think it'll still get me a TLE, but I want to try it anyway. Yeah. 30, 15, 30. Yeah, sliding window. Yeah, I really don't think sliding window will work. DP problem using 2 pointers from opposite hand. Maybe. Using a hash map to track the count of the largest element. That's what I'm trying. So, for example, in this example, I track where the 4s are. I find all the 4s. Since there are 2 4s, the answer for 4s is 2. And then I break that down. I look at the 3s. But I have to look at the 3s. Yeah, I basically still get an n squared solution. Optimize for question 4. Yeah, I don't have the answer to question 4. Sliding window plus something. Yeah. I can't think of what though. I feel like I'm still sort of bullish on finding the largest element. And then once you found the largest element, you break the array down into smaller subarrays. But I still end up getting n squared. That's the problem. You don't need ON, you need better than n squared. So you can get n log n if you want. If you can get n log n, it'll work. Yeah. Minimum rectangle to cover points. Yeah, I'll go through the answers in 7 minutes. Well, 6 minutes. Once the contest ends. Sorry. Yeah, sorry, Jyoti. Just hang on to your hats for a while. And then I'll go through the answer in detail. LeetCode question 4 available. Okay, I'm going to ask you, if you're, so Akash, if you're trying to advertise for code, I'm going to ask you to not do that. The goal of the contest, ultimately, the goal of this contest is to learn, right? Because winning the contest is not a prize. Getting better at what you do is the prize, because it's going to help you in your job. It's going to help you in your career. So I'm going to ask people to not share code. But if you want to discuss your answer here, you want to discuss the ideas behind your answer, that's fine. Just don't share the code. Yeah, sorry, Jyotish. Give me a few minutes. And then, yeah, you know what? Actually, you know what, Jyotish? Let's look at, you want question 2, right? Let's go look at question 2. Yeah, let's go look at question 2. Let's see what's up. Since it's official, I've given up on question 4. If people have any ideas to do it, make sure just share in the chat. If not, I'm gonna go through question 2 real quick for Jyotish. So you have 2D array points, where points I equals this. You're given an integer w. Okay, your idea is to cover all the points with rectangles. So the constraint here, there's only one constraint, which is the width of the rectangle, x2 minus x1, is smaller or equal to w. That's the width. There's no constraint to the height. So your rectangle can be super duper tall. You don't care. It can be infinite height. Right? So think about what it means to cover a point with a rectangle. Basically, the height is irrelevant, right? Because your rectangles are going to be of infinite heights. You only have to look at the x coordinate for each point. So one thing you could do is you can look at the first point. Currently, there's no rectangle, so you have to start a new one. And since you start a new rectangle at the first point, which is going to be 0, you keep going, right? You look at, you want to figure out which points are also covered by this first rectangle that you created. So since the first rectangle starts at 0, which is the x coordinate of the first point, it will cover everything from 0 to w. So w is 2, so it covers up to 2. So you basically iterate through all the points. If your points x, you ignore the y-axis. If your points x-axis is more than w units from the start of the last rectangle. So like this guy is w units away from him, so he's good. You don't have to start a new rectangle. But this guy is more than w units away from the last rectangle. So you have to start a new rectangle. So I drew a circle here. That's what it means. So now you are the start of a new rectangle, and you keep going until you find someone else who is more than w units away from the start of the last rectangle. So so basically this is the strategy here that you see on the screen. The catch is you don't have to ever look at the y-axis. You just look at the x-axis. Only the x-axis. You ignore all the y-axis. Yeah. How about we store our next target number for each element and store a hash map check? Yeah. Well, I don't know what I can't think of. You know what? I'm honestly a little bit pissed off, because you look at the chat, right? Everybody has good ideas for question 4, but none of our ideas work. So I almost feel like I want to come back later today. I know it's nighttime for you guys, but I mean, I'm going to come back later today and try and figure out, and try to do question 4 and see whether I can get it or not. And you guys can try on your own also. I'm sure people will release solutions after the contest. Like, by tomorrow, people will release solutions for question 4. But I don't want to look at their solution. I want to try it out myself. I want to see if I can figure it out. Yeah. Yeah. Anyway, the contest is ending soon. I hope that everybody has achieved their goals from the contest, which is you feel like you gotten a little bit better. Will you attend week? Yeah. So if you feel like you've gotten a little bit better, you've gotten a little bit better at programming, you've learned something, right? That's the most important part. And the second most important part is you have fun. I think that's the point of the contest. We all like programming and we want to have some fun. So since everybody's here, before you log off, quick plug. I stream every week. So I stream the bi-weekly contest if it's on. If there's no bi-weekly contest, I will stream the weekly contest. So I won't stream the weekly contest tomorrow morning or tonight, depending on where you live. I will stream one contest a week every week. So make sure to come back to my channel. Make sure to if you enjoy what I do, definitely throw me a like and subscribe. I answer all comments. You can ask questions about, like, if you want career advice or anything. Make sure you type in the chat. Some of you may know that I've been a FANG engineer for more than 10 years. And I teach now. So feel free to ask for questions. But if you watch the videos, like and subscribe, you look at other videos on my channel, that's going to help me out a lot. And I'll be very grateful for that. Yeah, okay. It ends. Will you attend? I will not attend weekly contests tomorrow. I will actually try to do the contest on my own. So I attempt all the contests. I either live or virtually. I just don't stream them. Will you live again? Yeah, I'll be live again next week. Yeah. Do penalties for unsolved problems add up? DP, but bad news, you get MOE. Yeah. Yeah, I don't know. I don't know. I'm stumped on question 4. I'm gonna have to think about it a little bit. Sarcastic, definitely. Every contest has its own learning and fun. Yeah, I'm glad you're enjoying the contest. That's the most important part. I'm glad that all of you guys like programming. I love programming. I've been doing it for 20 years. more than 20 years. 30 years? I don't know. Long time. It's a big part of my life. And I'm glad that all of you, many of you are much younger than me, are also enjoying this craft. The idea of building something, the idea of discovering something and solving a really difficult problem, man, that feeling is amazing. Thank you. You're welcome. Thanks to everybody for showing up. I'm very grateful for everybody coming to my channel. So now I'm going to go through the solutions since the contest ended. But before that, let me just do my usual plug. Okay. All right. We are discussing solutions for LeetCode Weekly Contest 128. Jump to specific questions using timestamps in the video description. Please check out the rest of my channel if you enjoy LeetCode content. I have solutions to different problems, as well as the hardest question 4s from previous contests. And I also stream every week for either bi-weekly contest if it's up, or the weekly contest if there's no bi-weekly contest. Like and subscribe to stay up to date on new videos. All right, question 1. Question 1, score of a string. This question is not super hard, so I'm going to be quick about it. You're given a string S. The score of a string is defined as the sum of the absolute difference between ASCII values of adjacent characters. You can almost ignore this. All you need to do is to know that the score of a string is defined as something, some function of adjacent characters, right? That's all you need to know. And the strategy for doing that is very simple. You keep running total. You do a for loop from I to the second last element, not the last element, second last element, and then you you do like total equals to, this is Python. Basically, ORD gets the ASCII code. So you take the ASCII code, you minus the ASCII code, and you get absolute value and add it total. So this one is fairly straightforward. Let me check the chat. You're doing it for 10 months? Yeah, no, it's the best part. Well, I started programming when I was a teenager. Like, actually, a lot of you guys are very young. I know some of you are like 15, 16, which is amazing. That's when I started programming also. But I was not as good as you guys at your age. You don't go for water today? No. Is it okay to use ChatGPT for help? I personally think that because, I think first, ChatGPT doesn't do a good job. And that's the first thing. ChatGPT will give you the wrong answer most of the time. And the second thing is, because it's a contest, you want to simulate, you want to learn something, right? So what's the skill that you're learning? Your skill is to program. Do you want to you want to master the skill of programming, or do you want to master the skill of what you call that? Would you rather master the skill of programming, or would you master the skill of using ChatGPT to program, which is prompt engineering, which is not easy actually, So it depends on what skill you want to master, right? LeetCode I don't know what's LeetCode's policy on ChatGPT. You might get banned, but the truth is, I don't care about getting banned. I care about learning something from a contest. So what skill are you trying to learn? Some people say you should use ChatGPT because then you learn how to, because that's the future. But either way, I wouldn't use ChatGPT. That's the concise TLDR. So question 2, minimum rectangles to cover points. So you're given 2D array points where points equals to blah. You're also given an integer w, and you want to cover them all with rectangles. You count how many rectangles you need to cover them all. So if you look at the constraint for the rectangles, it starts at x1 at 0. It goes to x2, y2. X1 is the left, x2 is the right, and y, there's no constraint on y. The rectangle can be as tall as you want. You don't care. The only constraint is the width of the rectangle. X2 minus x1 is smaller equals w. So the width of the rectangle is at most w. So how do you count how many points are covered by this rectangle? Well, the basic idea is you want to sort all the points first. You go from left to right. When you have a new point, right, every new point will start a new rectangle. And then you keep going until you find a point that is whose x-axis is more than w units from the x-axis of the previous point. In which case, you will start a new rectangle. Like this one over here. As long as the x-axis is less than or equal to w units from the start of the rectangle, you keep going. If you want to start a new rectangle, you just add rectangle plus 1, and then you keep going until you reach the end. So the code actually looks something like this. So you sort the points by their x-axis. I just do total equals to 1, and I start, my last is the start of the rectangle equals to the x-axis of the first point. And I keep going, right? I keep going. If my x-axis minus the last is larger than w, it means, oh no, I have to start a new rectangle. And then I add 1 to the number of rectangles I'm using. And then the start of the new rectangle will be my current x. And I keep going until the end, and I return total. So that's how I would tackle this. Your nationality. So I'm actually a Singaporean, but I live in the US for, I guess, most of my life. So I'm sort of American, essentially US based. What do you think about programming in the future? Will it still be years out to get a job in this field, but advance of AI will slowly become obsolete? I don't think the job of a programmer will become obsolete, but the skills you need to program in the future will be different from the skills you need today. If you look at the programming from like 50 years ago, it's so different from programming today. You don't have things like Python. You don't have a lot of libraries. You don't have like high level languages. Programmers in the 60s and 70s are still using punch cards. Have you guys seen punch cards, like these little cards with holes in them you put in the giant machine? Oh my god, that level of programming is so different from programmers today, right? The actual skills that you need to be good at programming is so different. But you think about it very carefully, the crux of programming is still the same. So the ideas of problem solving, the algorithms that you use to solve problems, the way you design data structures are still the same. They are the same in the 60s, 70s, 90s until today. They are still the same set of algorithms. You still use Dijkstra today. Yeah. The machine is different. The actual day-to-day task that you do to interact with the computer program is different. But the ideas behind it, they're the same. Yeah. Nobody uses a programming language that's 50 years old, but people use algorithms and data structures that are 50 years old. That's the interesting part. So if you understand those things, that will never change. Okay, question 3. Minimum time to visit disappearing nodes. So the question was, let me go through what the question is asking for and get rid of all this. Okay, so basically what the question is asking for is saying that you are given a graph that looks something like this. Okay, you want to find the distance from node 0 to all the other nodes. Starting from node 0, you want to reach all the other nodes. And you want to find the shortest distance. So it's basically like Dijkstra, but there's a catch. There's this thing called disappear. Disappear will tell you what time that particular node disappears. So if you want to use that node before that time, or you want to get to that node before that time, that's fine. If you get to that node after that time, then you can't do that. It's gone by the time you get to it. Okay? So those are the rules. It's basically edges with the source, destination, and length. And an array called disappear. Disappear will tell you when each node disappears. So in this example, node 0 disappears at time 1, node 1 disappears at time 1, and node 2 disappears at time 5. Okay? So so you can think of the answer as a sort of array. So, and at time 0, I can reach node 0, okay, because I start at 0. Okay, what are the children of 0? Well, the children of 0 are 1 and 2, right? So 1, its distance is 2, and 2, its distance is 4. This is like your to-do. Okay? So when you see the next thing you want to do is now 1 and 2, right? 1, unfortunately, because 1 disappears on time 1, to get from 0 to 1, you need 2 steps, and you need 0 steps to get to 0. So by the time you get to time 1, it will have disappeared. So time 1 is actually minus 1. Node 1 is actually minus 1 because node 1 is unreachable, right? So you strike that off your to-do. So 2 is 2 and 4. You can get to 2 from 0 using 4 steps. So 0 starts from 0, right? To get from to 2, you basically need 0 plus 4, which is 4. And this is less than the time that it takes to disappear. So 2 is fine. You just say 4. Right? So that's the basic idea. How do you do that? Well, basically that's exactly how you do it, right? At every step, you keep track of a to-do list. These are the nodes that you can reach next. The nodes that you can reach next. And you sort them by how far they are away from you. So you can use some kind of priority queue. So this is actually almost exactly like Dijkstra. If you look at Dijkstra shortest path algorithm, it's almost exactly the same. The only catch is when the distance is larger or equal to disappear, you don't add it. That's the only difference. Oh, wait a second. Where did my answer go? So this is how I did it. This is how I did it. So basically, the first thing I do when I see this kind of problem is I turn the list of edges into an adjacency matrix. So I turn like this edge list to adjacency matrix because I want to find, when I reach a node, I want to find its neighbors, right? To find the neighbors for a list of edges is ON, where n is the number of edges. I don't want that. Instead, if I have an adjacency matrix, then the time needed to look up any node's neighbors is basically O1. So my first step is almost always to turn this to the adjacency matrix. I use a dictionary or a hash map. Yeah. It's a nested hash map. It's a dictionary of dictionaries. So next thing I do is basically I have this thing called to do. And I use a heap. A heap is Python's priority queue. So this is a priority queue sorted by what is the distance to this node. So while the length of so while the length of to do is 0, I pop the next thing in the next cheapest thing. So at the beginning is only 0, right? 0 is only first node you can reach. And then I check all the neighbors. V are the neighbors, and W is the weight of the neighbor. So V, and then I check, okay, if the cost to me, the source node, plus my distance from this source node to the neighbor is larger than disappear, then I continue. That means the neighbor will have disappeared by the time I reach it. If not, then I will only push when the target node has not received a distance yet. Yeah. And if not, then I basically add rest is the distance to my source. So distance source plus W, which is the distance from source to destination. And that will give you the distance to destination. And then I basically do a heap push. Yeah. So that's pretty straightforward. I think it's the same as Dijkstra. You modify Dijkstra a little bit. So unfortunately, I got a timeout here. There's some kind of bug that I have in this code because I'm pretty sure the priority queue is supposed to work for this question. Yeah. Please share. So unfortunately, I don't share my LinkedIn ID. I might change my mind in the future. Right now, I want to decouple my streaming persona from my professional persona. So if I become a lot more successful at streaming, then I will add it to my resume and I'll add it. Then I'll combine the two and have LinkedIn. Sir, how to solve question 4? Well, sir, I don't know either. So I've got a very unsatisfying answer for you. But we'll go through it and see if people have some ideas. So question 4 is find the number of subarrays where boundary, let me get one where it's not so messed up. Find the number of subarrays where boundary elements are maximal. So return the number of subarrays where the first last element are equal to the largest element in the subarray. Okay, so basically what you have is, for instance, you have something like this, 1 4 2 3 3 2. Okay, or maybe I'll pick a better example. Let's say your example is 1 4 1 3 2 3 4 1 4. Okay, so you want to find valid subarrays from this array. So a valid subarray is a subarray where the first and last element are the same as the maximum element. So for instance, this will be a valid subarray because 4 and 4 are the same, first and last element are the same. Okay, and 4 is the largest element in the array also. So this will be valid. This is also valid. 3 and 3 are the same, and 3 is the largest element in this subarray. Notice that 3 doesn't have to be the largest element of the whole array, it just has to be largest in the subarray. So likewise, 4, 1, and 4 is also valid. Let me see. So this 1, 3, 2, 3, 4, 1 is not valid, because even though the first and last element are the same, 1 and 1, it is not equal to the largest element in the array. The largest element is 4. So 1 and 1 are not equal to 4. So that's the question. You have to count how many valid arrays there are. I actually don't know. So my first instinct is, just like many of yours, is to use some kind of sliding window. So let's think about sliding window for, let's say I solve for 1, right? But the thing is, after I have the solution for 1, it doesn't help me with the solution for 4 at all. So the thing about sliding window is that if the sliding window sort of like intuition behind it is, if you solve the answer starting from left equals 0, then getting from left equals 0 to left equals 1 should be cheap. Should be very easy. Right? That's the intuition behind the sliding window. If you solve the answer for left equals 0, you want to move to left equals to 1, well, it should be quite cheap. But unfortunately, that's not the case here. If I solve the answer for 1, it doesn't help me with 4 at all, because 4 is a completely different number. So the other idea I have, I think some people have ideas around. Oh, he found me on LinkedIn. Oh, okay. Yeah, I guess it's not a super secret. It is what it is. Yeah, so I think some people have ideas around dynamic programming. The way I sort of approach this, and I can talk about it, is I think of I want to find the largest elements first. So I want to find out the 4s. So I have 4, 4, and 4. There are 3 4s. So how many? So basically 3 choose 2 is 3. So there are 3 combinations there are 3 sub-arrays whose beginning and end are 4, and where all the numbers are smaller or equal to 4. You know all the small numbers are smaller or equal to smaller than 4 because 4 is the largest element, right? So start with the largest element first. 4, 4, and 4. Okay, this is my idea. I don't know whether it's going to work. And after I've done this, I noticed that now for elements starting 4, the answer is 3. So now I have reduced this into 3 separate subproblems, right? I've reduced this to 3 separate subproblems. I have this subproblem, and this subproblem. Yeah? So what happens on each of these subproblems? Well, 1 is just 1. 1 is just 1 here. Let's pick a different color. So now let's say 1. Let's say I look at this subproblem 1, 3, 2, 3. I can do the same thing. 3 is the largest element. Right? Since there are 2 3s, it's 2 choose 2, which is 1. So now I've reduced it to more subproblems. This subproblem and this subproblem. Since they are length 1, the answer is 1. So that gets interesting now. That gets a little bit more interesting now. So you can actually make it a little bit cheaper, I think. Yeah, so this is how I plan to tackle it. I did manage to try it out within the time limits of the array of the contest, but I'm going to try it out later and then see whether I can get the answer or not. Maybe I'll be able to get the answer. I'm not sure. So that's my strategy. Yep. So that's it for today's contest. I hope that everybody did as well as you were hoping to. As usual, remember the point of the contest is to get better at programming. It's not to win. You're not going to win. The people who win are like crazy. They do this in like 10 minutes. There's no way. yeah, it's no way I'll ever be able to win. I don't care about winning, but I want to get better at programming every day. And for myself, I also want to get better at like teaching programming every day, since that's what I do. So I hope I get better at explaining concepts to you guys also. If that was helpful to you, make sure to check out the rest of my channel, like and subscribe. That's always very helpful to me. If you have any question, post them in the chat. If not, then I think that's the end of the contest. Yeah, thank you. Well, I appreciate you very much, RedFinance, for coming back week after week. You're welcome, Scientific Coder. I like your name, Scientific Coder. I'm curious if you're a data science person or you're a scientist who's using this to code. Yeah. I think this is easy in monotonic stack. Curfew. Monotonic stack. Oh, interesting. Wait, how will you use a monotonic stack? Interesting. I don't know. I'll think about it. So, Kafil, if you thought of the answer, make sure to write in chat. Yeah, welcome back, Rohan Sharma. I see you week after week. Thanks for being a supporter of the channel. You're welcome. You're welcome, everybody, for live stream. I hope to see all of you guys next week. Yeah, there's a contest tomorrow morning. I guess for you, most of you guys are in India, which is tonight for me. I hope you guys can enter that as well and have fun. All right, so that's it for today. I'm signing off. Thank you very much. Bye bye.